Ever wondered why it's so hard for some people to kick an addiction? Is it just a lack of willpower? Or is there something more complex going on under the hood? Addiction, a term often misunderstood, is not just a series of bad habits. It's a complicated dance of brain functions and chemical reactions. It's more than just a fleeting desire. It's a demanding chorus that drowns out the whisper of self-control. To understand addiction, we must delve into the fascinating world of neuroscience and explore how our brains react to addictive substances or behaviors. You see, your brain isn't just a lump of gray matter. It's a highly intricate network of nerve cells or neurons communicating through electrical and chemical signals. Now let's break that down a bit. Imagine your brain as a bustling city, and neurons are its citizens. They communicate with each other through a language of electrical signals and chemical messengers known as neurotransmitters. This communication is essential for everything we do, think, or feel. It's the very essence of our consciousness. Now let's delve into one particular neighborhood of this city, the reward system. This system is responsible for the feelings of pleasure and motivation we experience. When you eat a piece of chocolate, for example, your reward system lights up, encouraging you to repeat the behavior. However, just like in any city, there can be troublemakers. Addiction is one such troublemaker, and it's a master manipulator. Drugs or addictive behaviors stimulate the reward system in an overdrive, flooding it with neurotransmitters. Over time, the brain adjusts to these excessive levels, demanding more and more to achieve the same sense of pleasure or relief. The brain essentially gets rewired. This is where the crux of addiction lies. It's not a matter of willpower or morality. It's a profound shift in your brain's functioning, where the pursuit of addictive substances or behaviors becomes an overpowering compulsion. So addiction essentially rewires your brain, turning a source of pleasure into a relentless demand that must be satisfied. But the effects of addiction don't stop at hijacking your brain's reward system. Over time, addiction can lead to long-term changes in brain function. Let's step into the realm of neuroscience, where we can unveil the profound impact of addiction on the brain. Prolonged exposure to addictive substances or behaviors can cause significant changes in how our brains operate. These changes can be seen in various areas, starting from learning and judgment, to decision-making, stress, memory, and even our behavior. Imagine your brain as a complex highway system. With addiction, it's as if some of the routes are blocked or rerouted, causing traffic to be redirected in ways that aren't necessarily beneficial. This manifests in our ability to learn new things, make sound judgments, and make rational decisions, all of which can be severely compromised. The stress system in our brain, which is designed to respond to threats and danger, can also be thrown off balance. This can lead to increased sensitivity to stress, and in some cases, an inability to cope with it effectively. Our memory and behavior are not left untouched either. Addiction can lead to memory loss or difficulties in remembering. Changes in behavior, often leaning towards the negative, can also be observed. These can trigger a cascade of problems, from health issues to relationship breakdowns and social complications. So the impact of addiction goes far beyond the immediate pleasure or relief that the addictive substance or behavior provides. It's a long-term damaging relationship with your brain. But here's the silver lining. The brain is a resilient organ. It can heal and recover from the effects of addiction. This is due to a remarkable phenomenon known as neuroplasticity, where the brain can change and adapt over time. With the right treatment and support, those grappling with addiction can recover, regain control, and lead healthy, productive lives. So remember, while addiction can change the brain in powerful ways, there's always hope for recovery. After all, the brain is our most adaptable organ.